Welcome friends, today's topic is water cement ratio in cement concrete. So let's get started. Here is the question. Discuss water cement ratio in cement concrete, or what is the significance of water cement ratio in cement concrete, or what is the effect of water cement ratio on strength of concrete? What is Abrams law? Water cement ratio in cement concrete. So this point will be covered. In actual, water required is about 0.50 to 0.60 times the weight of cement. The ratio of the amount of water to the amount of cement by weight is termed as the water cement ratio. The strength and quality of concrete depends upon this ratio. The quantity of one bag of cement is 30 liters. The water cement ratio is equal to 30 by 50 is equal to 0.6. The amount of water should be such that it should impart reasonable degree of workability to concrete. The excess water affects the strength and durability of concrete. Significance of water cement ratio in cement concrete. So this point will be covered. The minimum quantity of water should be used to have reasonable degree of workability. The excess water occupies space in concrete, and on evaporation, the voids are created in concrete. Figures of voids created in concrete. So this is figure 1 and this is concrete, and you can look the voids. This is the another figure of concrete, and this is the small voids in the cement concrete structure. Thus the excess water affects considerably on the strength and durability of concrete. The strength of concrete is inversely proportional to the water cement ratio. In general, it may be stated that addition of 1 extra liter of water to the concrete of 1 bag of cement will reduce its strength of about 1.47 Newton per mm square. The water cement ratio for structure which are exposed to weather should be carefully decided. For instance, for structures which are regularly wetting and drying, the water cement ratio by weight should be 0.45 and 0.55 for thin sections and mass concrete respectively. For structures which are continuously underwater, the water cement ratio by weight should be 0.55 and 0.65 for thin sections and mass concrete respectively. Compressive strength for various water cement ratio. So this is the table. In this, net water cement ratio by weight, and this is probable cube crushing strength in Newton per mm square for 7 days and 28 days. This is 0.35. In 7 days it is 40 and 28 days it is 52.5. Next is 0.40. This is 35 and 47. 0.45, 30 and 42. 0.50, 25, 37. 0.55, 22, 33. 0.60, 18, 28. 0.65, 15.5, 24.5. 0.70, 13.5, 22. 0.75, 11.2, 20. 0.80, 10.5, 17.5. Effect of water cement ratio on strength of concrete. So this point will be covered, and Abrams law. This point will also be covered. In ordinary construction, it is not possible to eliminate all the air from the concrete, so that there are some entrapped air voids even in fully compacted concrete. Table shows typical values. So this is the table of appropriate entrapped air content for various sizes of aggregates. This is the column of nominal maximum size of aggregates in mm, and another column is entrapped air content in percent. In it, 10, and this is 3, this is 12.5, and this is 2.5, this is 20 and 2, this is 25 and 1.5, this is 40 and 1, next is 50, 0.5, 70, 0.3, 150, 0.2. Assuming full compaction and at a normal temperature and given age, strength of concrete can be taken to be inversely proportional to the water cement ratio. This is known as Abrams law. Figure shows this statement and also represents the effects of partial compaction on strength. So this is the figure of relation between strength and water cement ratio of concrete. This is the figure, and in x direction this is water cement ratio, and in y direction this is compressive strength. You can look the picture. This is vibration and this is hand compaction. Next is fully compacted concrete, and the starting point is insufficient compacted concrete. Abrams law is a special case of a general rule formulated empirically by Feret. Fc is equal to K, and in the square of Vc plus Vw plus A. This is equation 1. In the equation where Fc is equal to strength of concrete, Vc, Vw and A is equal to absolute volumes of cement, water and entrapped air respectively. K is equal to constant. It will be recalled that the water cement ratio determines the porosity of the cement paste at a given degree of hydration. Thus, the relation of equation 1 accounts for the effect of the total volume of voids on strength, that is, entrapped air, gel pores, and capillary pores. Generally, the degree of hydration increases with an increase in age, so that strength increases. This effect is represented in figure of concretes formed with ordinary Portland cement. Influence of age on compressive strength of ordinary Portland cement concrete at different water cement ratios. So this is the figure between water cement ratio by mass and compressive strength in megapascal. And another side is PSI. So this is the values of 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. In x direction, in y direction is 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And the another side of PSI is 2000, from 0 to 2000, 4000, 6000, 8000, 10,000, 12,000, 14,000. And this is the age from 1 day. 1 day, next is 3 days, for 7 days, 3 days and 7 days, then 28 days, 3 months, 1 year, 28 days, then 3 months and 1 year. So the continuous line of 1980 and the dotted line is 1950. So this figure gives the information about the influence of age on compressive strength of ordinary Portland cement concrete at different water cement ratios. It should be emphasized that strength depends on the effective water cement ratio, which is computed on the basis of the mixed water less the water absorbed by the aggregate. In other words, at the time of mixing, the aggregate is assumed to use up some water so as to reach a saturated and dry surface condition. So dear friends, this is all about water cement ratio in cement concrete. Write your opinion in the comment section of this video. You can also check the playlist related to construction materials and building materials in my channel. If you enjoy this video, please like it, share, comment, and also subscribe my channel for getting latest upcoming construction materials and building materials related videos first. So dear friends, let's meet in another video. Thank you very much.